So Bill, I work at the local bike shop around here, Bicycle Chain, and Chip's been a long time customer. I've worked on his bikes for a long time. And he was like asking me some ideas, and I was kind of trying to figure out a way. Trimming a wheel for a lot of people is a mystery, and there should be an easy way to attach this little thing to a bike and pretty much make it kind of idiot-proof. So luckily we found a little distance sensor here, and I've kind of spring-loaded it so in a pulley. So with this little controller board here is we've got set up to where once we...
The camera's on the other side of the fence.
Yeah, I don't know if that one.
You zoom it way out, we've zoomed it way out before.
So what you're doing is you're going to true that wheel.
I'm going to true the wheel, not with knowing how to true a wheel, or
Keyboard out of the way. And the control panel has to, yeah, got it.
There you go.
Cool.
Oh, yeah, that's why we're here.
And while he's just doing that, the device is, I used the micro review for that, and I'll pass that around if you haven't seen it before. It's an Arduino with a embedded OLED display.
so kind of the idea is this is not a very good wheel. This is a really old, bent-up wheel. So I'm trying to get it to where right now we have it set up to once you hit the button, you'll spin it around at a certain rate. Within a certain amount of time, you get back around to a fixed point, hit the button again, and it's going to go ahead and average out and get you a center line. So the idea with that is it doesn't really matter where the sensor is relative to the wheel, it's going to set itself up. So right now,
Oh, it's still taking the average.
so there it took 76 measurements, set the center line up, so it's actually about one tick off from center there at that point, depending on see how far it's going out. Pretty far. Is that a set distance that we've determined?
Yeah, it's a half-inch total travel, and it's 1,024 samples, so whatever that works out to be. I think I figured out it's like a millimeter per count or something, roughly.
Somewhere down there. So my idea right now, or the current problem I'm having is it takes a lot of to get that thing to go around in the same amount of time each time, and to have the numbers correspond to each given spoke. So when you get to, say, number 4, you're at number 4 spoke, and it says it's off point or -1. That's going to be a quarter of a turn here. It's about the same throughout the wheel on how much it's going to take to move the rim. And
So you have to stop at each spoke.
stop at each spoke. That spoke would be -7. You go to that spoke, -1. You know you need to go back to the spoke, tighten that up a quarter of a turn, and it's going to move that over. Right now, it's taking so many measurements, it's almost too much data. It kind of needs to be...
No such thing.
It needs to be simplified a little bit. So I've been working on trying to figure out how to get time out of the equation. I think that's probably not really repeatable. So I'm thinking, Chip, if there's a way we can put another sensor on here, one that's like maybe a mouse, kind of an infrared distance
An IR
sensor.
thing that trips on each spoke thing so that
Yeah,
you can
more or
count the
less.
spokes.
The
spoke finder.
Most wheels are going to give you, say, they're going to be a 32 spoke or a 36 spoke, or that's all you're going to have. 28, there's some nicer ones with 28. So really, any real factor of like 12 is going to be okay, because then it'll be able to count the spokes, and if you get 64 numbers, you can average out and get the right spoke. But being able to figure out that once you're at this point in the wheel, as you're actually working on it, it's gonna be at that spoke every time. I guess we could probably do that with a mouse
An optical
Style,
encoder
optical,
kind of thing
just
that's running on the wheel.
trackball, almost type of a deal.
If you wanted to be fancy, you could use the stepper motor, have it do the rotation automatic.
Then worry about if this thing gets bumped or moved around or anything. Again, it's really kind of be idiot proof. I mean, this is not for a mechanic at a bike shop. This is for some guy that wants to just work on his, work on his bike in his garage and doesn't have that truing stand like this. This is a pretty fancy rig to have, and you can true a bike in, or a true wheel in the bike just using the chain stay or the seat stay. And I'd like to be able to mount this to that and have a little, maybe even a little infrared thing that's going to give you distance there.
Yeah, there are short-range infrared
Distance.
sensors that would see the spoke and not see the front of your shirt.
Okay.
That basically,
Okay.
they're arranged at angles and everything to detect the presence of something anywhere from a fixed distance to a relatively narrow range of distances.
Yeah.
And one of the Japanese manufacturers Sharp
Sharp, yeah.
makes those things by the bazillion.
Okay.
And there's probably one that would reliably detect the spoke.
Yeah. I do a lot of wheel building, and this kind of came up,
Is the tire typically mounted?
usually, yeah.
So
it is.
the valve stem will look different and it'll be between spokes?
Yeah. Mhm.
So
I mean,
probably
over
find
here,
that
you're
as
gonna
well.
have where, in the middle of the two spokes, there's a big giant metal thing sticking out.
Yeah, so you can count whether you've done 36 or 32
Mhm.
or
Mhm.
using.
That's gotta be for the real serious bikes, not for a 12-year-old riding his bicycle.
No.
You're gonna spend that much
Well,
time to true up a
bike
wheel?
that's gonna be ridden by a 12-year-old is gonna be a small wheel. This is more of like an adult-sized bike. There's smaller wheels, you can't really true those. You just kind of hit them on the ground until they're straight. This kind of a wheel is gonna rely on a very specific tension on both sides. And you can really play with that, with the spoke tension all the way around the wheel. But with doing a lot of builds on wheels, you want to be able to give them a build sheet that has the wheel run out and lateral and both every direction and the actual tension of the spokes. There's a really nice fancy gauge you can get that'll tell you that, but really you just need an overall average that's about even to make it balanced. But,
So one of the thoughts were that just so you could have a printout that would show, here's what the profile of the wheel was before Eddie trued it, and here's the profile of the wheel now. And so you could actually just kind of show that what the truing process.
yeah, we should be able to put this into an Excel file and just use that for future wheel trues. See what happened to the wheel while ago.
I got a question. How do you know that the rim is actually centered between the two sides of, I don't know what you
Dish,
would call it?
it's the wheel dish, it's
Okay.
the rim's position relative to the
Right.
end caps of the hub.
Right.
Yeah.
So how do you know that?
There's another tool that you take the wheel out and you check both sides. This kind of concept is kind of going on the assumption that the wheel's gonna be pre-built, it's gonna be built right, so
Right.
it's gonna be centered correctly already. Yeah, there's the big wheel dishing gauge you stick on there, it kind of tells you. Or you can
Because you
just-
could also, you could improve this to the point where you have a sensor both sides,
Oh, yeah.
right?
Mhm.
That'll tell you what the distance is, and if the distance is not the same, you know the wheel's not in the middle.
Mounting might be an issue, just with the fact that you're gonna have a big tire off of this thing.
Yeah.
But, yeah, I don't see why not. Especially if we get into the infrared sensors a little bit more.
Yeah.
At a certain point, though, you just say, bag this and put it on a real chewing.
I mean, you're really doing the exact same thing when you put it on here. You're just using these little fingers to kind of figure out where you are. You spin it around until it rubs it, and you tighten or loosen it depending on how.
But that
the overall
automatically
tension
takes care
is.
of dishing too, doesn't it?
Not really. These things are never right. You set them up and you're banging them around with wheels and stuff. So it takes a special gauge to even get this thing to dish everything correctly. So usually I'll use the actual dishing tool. I'll take it out of here,
Oh, okay.
put the gauge on both sides to see which way I need to go. And about 1 millimeter out is not really noticeable. It's not going to affect anything. Any other questions? Yeah.
What are you gonna charge to trim the wheel?
$20. Yeah, it's gone up. It used to be 10
I was
10
surprised
years
at that
ago.
low, actually, when I said, wow.
So-
Well, that's truing. That's doing minor adjustments. If I need to go and check get the gauge out and check the tension of all of it and retension it, that's gonna be about $60. It's, aside from banging on the ground, that's about all you're gonna get. And this is just a 26-inch wheel. Now they've got them so big that this rig won't even work. We've had to put extensions on here. So having something that clips to the bike is kind of nice. If you guys want to play with this, come check it out.
So I guess the two questions for the group are, one, since the way it's taking the average now kind of relies on Eddie spinning it at a constant rate over the circular wheel, because it's an average over those 76 data points it took, would there be a better way of detecting the studs? And a sharp IR sensor might be one to look at. Another might be if you put, if there was some magnetic sensor, I don't know. But then the other question I have is it possible to do a non-contact version of this? Do you think those IR sensors would get tripped up by the crud or scuffs on the rim of the bike? And
Maybe in the black sections, it might absorb it enough to, because it's rubber, it's going to absorb some of that.
yeah.
But
Need the Hall effect as well, just with the metal spokes. Spin it by and look for the between bar, and that's a non-contact.
I would think that would be a little reliable.
I would think that you could use a photodiode and just a LED laser pointer type light. You're gonna get lots of specular reflection off of the spoke and none off of air.
Are the spokes made of? Eddie?
they're steel or titanium, just a few alloy spoked wheels out there.
So they won't always be magnetic.
No.
Not necessarily, no.
How about the nipples though?
The nibbles are usually alloy in the higher.
You could put a low frequency signal through a coil, and when the metal got close to it, it would detune that. In other words, every time the spoke came around and got close,
Mhm.
it would radically detune that.
Counting spokes probably is not
So,
hard.
so yeah, finding the spokes and counting the spokes is probably the
That's
easiest part of
easy,
this.
but detecting how far you are away without touching the rim, that's the hard part.
Well, the linear potentiometer we have here, Gene's got one and had a chance to play with it. It's infinite precision, I think you said, right? Yeah, since it's analog. So,
The resolution of your A to D converter then becomes an issue.
and I'm just using the 10-bit converter that comes with the Arduino here, but it does have a duty cycle, according to data sheet, of 500,000 cycles.
That's a lot.
I got already the decision,
Not really terribly. So contact is the way to go, and then the question is how you detect the spokes. If it's Hall effect or a detune
Okay.
coil, or if it's
Has anybody heard of a dial gauge?
I use one on my saw.
So, for about $100, or you could probably pay as much as you want, but you could get a gadget, and it's got a little flexible thing sticking out, and you mount it, and so it's sitting against the rim, and it automatically, you could just, you can zero it, and then as the thing moves around, that dial gauge is.
yeah.
Yeah, we've got
That's
one.
what-
There's one that mounts on to
Right,
here
right.
to
So
two of them actually, to do both measurements.
So the question in my mind is, what are we gaining with the,
I wanna be able to put this in somebody's hand and say, here, strap this onto your bike and tree road. It really should be dumbed down as much as possible.
finding a cheap source of dial gauges is
The
not,
dial
not
gauge
as
is-
interesting.
Yeah, no.
And then the other thing, being in the shop, they could use this, they could create that report that
Oh,
you,
sure.
that you can give to your high-end bike person to say,
With the
here's-
dial gauge, you have to read the gauge, and you have to know where to spin it, and
Right, I
watch
mean,
the
with this,
gauge.
eventually, you could say,
This thing will just tell you.
it'll say, turn this spoke in a quarter turn, turn this spoke out a quarter turn.
Correct.
You could potentially automate it so that, like you said at the beginning, anybody can.
Yeah, like this, the distance of the hub flange on either side's pretty set on all bikes. So it is just a matter of triangulating out and figuring out how much, you know the thread pitch of this. So you can do a quarter turn is gonna move the rim exactly 1/10 of a millimeter that way.
and those instructions could be on that OLED display for that amateur wheel truer.
Yeah.
But I like the report too.
Yeah, I mean,
It's really, usually when you're looking at the reports that we get, it's actual spoke tension. But to get a gauge that's accurate enough at such a low tension, these are actually low when you're really thinking about wire tension. It's kind of hard. The only other way we've been able to do it is with a little guitar tuner. You can actually check the tension of the whole wheel. Any other questions?
Possible idea for the contact was measuring distance and location. You have something kind of fastened to the bicycle frame, little wheel that kind of pushes it against the edge of the rim. As you spin it around, it's actually measuring the distance in and out. It's also measuring how many revolution of the small things going. So as you come back around, so one sensor that goes back and forth as well as the wheel. So
an optical encoder disc on that wheel that's running on the rim right now.
it's actually measuring, it's being pushed against it to give you the contact. And actually, it's a long arm, it gives you even more precision than pushing it smaller.
You'll, when you have a chance to walk up, you'll see, I mean, the disc you have on there is what, an inch diameter or something?
It's about.
So it would work, I think, for what you're describing.
The only problem is that if it slips, you kind of lost it, it's just because it,
Yeah.
That's true.
And that disc has to be perfectly round with the hole in exactly the center.
Oh. Yes.
Because if you get a flat spot in that disc, or the wheel is off center, I mean that now it's a cam instead of a circle.
Oh, yeah.
If you're using the same wheel to count revolutions, so that wheel is turning around, and as you are to determine how much runout you have on the wheel, if your wheel, let's go crazy and put it 1/3 of the way instead of dead center on a diameter, so it's 1/3 of the way, when it's at the 2/3, it's going to be a substantially different measurement than it is on the 1/3 side.
Actually, there's two averages going on here that may address, one of those averages might address your thing. The first is that 76 data points on the circumference of the wheel, which gives you the center line. The second is that it's averaging the last, I think, 10 measurements. So you could probably work it out to where you could take an average of that wheel, you still could get your 32 counts, and you could eliminate that source of error. Because I think that's,
You got enough horsepower, right?
but I think that's a good point, I hadn't thought about that. That's a source of error for sure. You have to average out somehow. Because you can get crud on that little wheel, even if the wheel's good. it'll get
Yeah,
the crud
yeah. If
from
it picks up some brake pad dust or
Yeah.
mud,
Yeah, the non-contact would definitely.
Eliminate that whole issue.
Yeah.
It would be also I can't imagine how, but a feature that allows you to put on a little display. If you tighten this thing one more quarter turn, that spoke's gonna break.
Yeah.
We've been keeping track of this. That spoke now has 200 pounds of tension.
Well, a lot of a lot of people try to true their wheels at home by themselves, and they don't realize that they can loosen as much as they can tighten. So, going around once tightening and then going around again loosening is always a good call. Some of the, especially the carbon, a lot of the carbon rimmed wheels now, the rim is so strong that when it goes up to tension and then it goes way up really fast. So you can snap a spoke with a carbon rim very quickly.
You just want to be able to have the customer screw up their bike so much that they have to come in.
Yes, I do.
He's got a great deal
It's
on
$60
spokes.
for a spoke replacement.
Well, no, you actually could produce a product here, you could sell these suckers.
Yeah, that's the idea. It's cool, cool playing with these things, for sure. It's pretty neat. In the really, Chip was saying the enclosure can be tiny, really small, so, getting it, compact is kind of key also.
I mean, your battery's gonna take up more space than most everything else.
Yeah. We got a little dynamo right here. Spin it a
There you
couple
go.
times and good to go.
Super cap.
Yeah. Yeah, so here.